Hi, my name's Bob Grinier, and I'm a volunteer with the Martin Fleischmann Memorial Project. So welcome to this 5th February 2023. If you can hear me, that would be good, and if you can see the image, that would be good too. For those that can, if they can hear me, hi Corky, hi Join the Technicians, hi David Boutelier, hi Watkins Incorporated DIY Projects with Chauxis, hi Artifact, hi Cosmic Dave, hi Chomp41, hi John Watson, Hayden Gordon, Doherty, and hi Rhett Oracle. So you can hear me. Okay, I'm missing my rather nice camera. I have this one, which is not terrible, I guess. And I also have this one, which is a little bit choppy because it's coming off the Mac. So I still haven't solved that, but I've got a better setup today than I had in the last time we did this. Okay, so my question here today is, can we run the world on cow farts? Well, look at that little adorable Frisian red and white cow there that's a newborn. This is off Wikipedia. The link is at the bottom there. And cows are getting a bad rap recently in what we're expected to think as the next thing to think about, given the sort of concepts of so-called climate change, upgraded from global warming, the 1971 kind of thing that was invented in Tanzania, and I unfortunately believed for most of my life, but anyway, it put me in this direction, so some good has come of it, I suppose. And yeah, I like eating meat. Not everyone likes eating meat. The cow, obviously, where I lived in India for the best part of a decade, is a sacred animal. That's except in a couple of states, one of which I actually lived in, Kerala. But that being said, I have seen with my very own eyes ladies collecting cow pats and making them into standard sizes and drying them out on granite rock in the sun in Tamil Nadu in southern eastern India. And these are sold, and it's a living for those people. And they burn the rather dirty fuel of the cow pats to cook their food. Of course, that isn't the reason why cows are getting a bad rap. The reason they're getting a bad rap right now is that, well, it's methane. And the molecule for methane there, again, off Wikipedia, the link is there, you can see on the bottom or center left, is CH4. And from The Guardian, a bastion of all things we should conform to, that link there, they are talking about how cow farts should be explained to children when they have climate questions. Of course, the children are the future, so if you can program them young, then you won't have to force them to do something because they'll think it's the right thing to do, like I did. And anyway, so one cow can produce up to 200 kilograms of methane in a year, and part of this is due to their burping, and the other part of it is due to their farting. And that's about as cleanly as I can say it. Of course, the poo does release something later down the line, but anyway. So they're getting a bad rap. So my friend Henk Uren in the Netherlands there is surrounded by wonderful pastures and a golf course, by the way, but anyway. And they are containing these rather lively looking Frisian cows. And there is a big drive to reduce this incredible productive cow and beef production and dairy products that are produced in Holland and in many other countries. And it's all in the name of this so-called global climate change. Now, why is that? Well, methane apparently is over 80 times more powerful than carbon dioxide. This is the story we're told, as a warming gas on a 20-year time frame. This reference comes from the World Bank, and it's referring to gas flarings. And in the same article, which you can get at the link down there, it talks about gas flaring. And this goes on around the world where it's not practical, or they don't have the equipment, or it's not going to give a good enough, quick enough return or whatever, to have liquefaction of that gas. And rather than have something go into the atmosphere that's 80 times more powerful than the carbon dioxide, they flare it off, producing carbon dioxide predominantly. And that 144 billion cubic meters, if it's burned, as in the H and C's, the hydrocarbons are burned to carbon dioxide and water, that would, according to that very article on the World Bank, provide all of the energy for sub-Saharan Africa. So for all of those people living in sub-Saharan Africa, which includes the second and third most populous states of Nigeria and South Africa, they wouldn't need any other energy. They could just use that gas, which is currently burnt all over the world. But I think we can do better than that. I think we can do better than that. And I'm going to argue here as the first part of a quick look at the GEET, which is now a system which, because of its patent in 1998, is actually patent-free now, or rather the patent has expired. A number of years ago, Paul Pantone made available the basic devices for anyone to use and make for personal use. And that's very gracious of him, but in reality, that's something you can do with a patent anyway. And so that's one aspect. Now it is patent expired. You know, we can work with this and make embodiments as our hearts please us. And what are we looking at here? Well, over on the right, you have maybe something that is a hydrocarbon in here and a bubbler. And the bubbler causes a vapor to come out here, goes through this valve into this port. It comes along here, and this is a tube, and inside the tube, concentrically, there is a metal rod. It doesn't need to be metal, it can be glass, which you can look at from some of the videos that have been done over the years. And it goes into here, and you can see there's this cone on here, and then it does whatever it does here, which we'll talk about a little bit more later. And then it goes down the little gap between here and here, all the way to the other end. And what you can't see here is ideally there is a concave or a cavity at the end here. Okay, and then it comes out here, and it then goes around here into the intake of the engine, boom, 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 and the exhaust from the valves or whatever, they come through here and through here. Now, this is effectively very hot, one would think, if it's coming from the engine, if it's a traditional petrol coming out here, but whatever, the exhaust from whatever goes on in the engine comes along this outer concentric tube, and so it's got the hottest bit here if we assume this is coming out hot, and as it goes down here it's kind of heating up the thing that's creeping past this constrained area here, and so on. So there's going to be some thermal transfer there, but there's also going to be particles in here that are charged going in this direction, and there are going to be particles in here that I'm going to explain to you will certainly be charged and will likely, through turbulence, be forming into charge separation and clusters as they come down here. And so you've got charges moving this way, charges moving this way. These are clusters. Something goes on in the engine when they come through here, and then it comes out here, and then it goes out from the exhaust, and you can actually see the exhaust has a valve on it, so you can actually divert some of the exhaust back in through the bubbler. And so you kind of have a virtuous loop here. And this kind of reminds me of the so-called closed loop system of one Dr. Roy Shinamaza. And Are they similar? I don't know. There we go. And down here you can see there's an auxiliary bubbler valve for non-petroleum fuels. And we're going to look at some of these so-called non-petroleum fuels that he mentions can be used. He very glibly mentions them or in passing, but he's kind of making a thing that basically you can use pretty much anything with this device, like whatever's available you can use. But I don't think it's quite like that, but I think we can narrow it down, and we can narrow it down with what we've learned over the last 6-7 years. Okay, so there is an air mixture here to increase the amount of air coming in here. Of course, that will have predominantly nitrogen and some oxygen going in there. And there we go. So that is the system. I imagine if you've got it in a kind of closed loop or partial closed loop, you might want some of the gas going out here and some oxygen going in here and nitrogen going in here. But I guess that depends on what the fuel mixture is here and the sort of auxiliary fuel here and the starting fuel. So it does say that you need, for instance, petrol to start it off, a good hydrocarbon to get it going. And once it's going, then you maybe can switch over to other materials or have a mixture in here maybe. But it typically starts off with fuel, as I understand it. Now, this diagram is from the teslatech.info store, where you can get diagrams and plans on how to build this, and it has a basic how to build with a bill of materials that you can use to retrofit I think a 2-stroke or up to 10 kilowatts. But he's saying we're going to allow people to produce for their own use up to 10 kilowatts, which is probably what you would need for a home. However, I don't know how that patent can be defended now that it has expired. So thank you to Jean Naudan for producing this image, which is on this site. Now, when you listen to what he's talking about in his videos, he's making a point, and his son is actually in one of the videos I shared on remoteview.icu, that there is 2 ends, and they have these interesting magnetic properties, but one is a outie and one is an innie. We have a yin and a yang going on here, and it's interesting that it has a cone and a flat end. I don't know if that's exactly how it is or whether that's just the bar stock. Another interesting point is that if this is horizontal, it needs to be twice the length of a vertical one, and the argument is that it is sucking electrons from quite a distance away. This is what he says. I'm not minded to necessarily wholeheartedly agree with that, and I'll discuss what I think is going on in future videos. But he says when it is like horizontal, it's let's say it's close to the ground, it can't grab what it needs to grab from the full radius around the tube, and so you need twice the length when it's horizontal. That may be the case. I think it's actually reasonable given what we know. However, what we're seeing here is something that is basically a cone, a truncated cone. That is very similar in the yin and the yang sense to the truncated cones we have in our yin and yang. And we know we've got a toroidal bubble in the cavitation system in ultra. And we know that if you're going to get a bubble, there must be a pressure change. And in fact, a lot of what's going on in here is you've got an increase in pressure at this end. You will have vortex formed here. You will have another effect going on, which I talked about when I was talking about the ultra experiment in the C.I.C last year. And then you've got something going along down this edge here, which is causing all kinds of turbulence, right? And moreover, it's very difficult to have gas coming in here and turning a corner without that producing some sort of vortex, okay? So there will be a vortex here. And if we look at the work of the inflow system by the group in Russia, by Klimov, they deliberately enforce a vortex, and that might be something that people will consider. But it would be extremely difficult to end up in a scenario where that's my mugshot, where gas is coming in here and it doesn't start inducing a vortex. So expect a vortex. So you're gonna have a toroidal thing here, and you're going to have a vortex with the toroidal structure going on. And that's before it starts to squeeze down here. Now this is pulling at this end, so it produces a vacuum at this end. And you have a vacuum as the material comes from here, where it's kind of like pressurized and maybe cohering. It gets to this point, and it goes into effectively a big pressure drop. Now, I'm not going to go into the full detail in this presentation today because it's something else that I wanted to share. But I can tell you with 100% certainty that we have created ball lightning in Vega experiments, and there's a particular series of experiments done by Henk in Holland, in the Netherlands. And in those experiments, there was a ball lightning a number of times created that was persistent for a fairly extended period of time, and then it would destabilize from its umbilical and it would launch itself into the quartz sheath surrounding the anode. And I have shared macro photography that I took where it explicitly shows that these are exotic vacuum object impact marks. It has beautiful, beautiful detail, which I will go in yet another presentation. So, and this has been recently replicated. And so we know for a fact this is easy to replicate, and it is 100% certainly ball lightning, and it is 100% certainly an exotic vacuum object, and it has many of the aspects that we've talked about in recent years that lead us to do transmutation. So he describes in this work that at this end you get like a plasma ball. He calls it plasma. But he says it's kind of not hot and it's in a vacuum. Now, other examples of where a system produces NENA where you have a pressure drop, I can give you another example. Not just the Vega experiments and the recent replication of Vega experiments that it was shown publicly, not the one done in Germany that's not been shown publicly. But in the work of Leclerc, he had a pump, and it went through a pressure drop, and that pressure drop goes through some cut holes in aluminium, and that produced fusion and all the way up to elements very, very high. But of course you've got aluminium in there, and you've got polymers and all kinds of things going in there. Still not a lot, but you have aluminum in there for those that are in the States. Okay, so the pressure drop creates specific conditions, and there will be pressure drop going on in this system as well. Now, on the Rex research site, there is a Chiropoulos who also looked at exotic vacuum objects, and he considered that there was something that I talked about when I was talking about the ultra work called the Rank-Hilsch vortex tube. Okay, so I'm saying you will get a vortex whether you like it or not when you have this gas coming in here and turning a corner. It will be very difficult to get this lamina going around here, and as soon as it's off center, it's going to produce a vortex. And so if you have a vortex coming down here and it hits a cone at this end, you then have a toroidal structure formed here. Hot gas gets forced down either side of the cone, and cool gas comes back through the middle. So we've got our bubble material coming down here, whatever temperature it is. Let's call it ambient temperature. It hits this area here, and the vortex forces colder air down the middle, and it forces hot air down the side. Okay. In addition, as this stuff goes down the side, it's hot. And it's turbulent, extremely turbulent. Okay, and you can see here that the gas emerging from the hot end can reach temperatures of 200 degrees centigrade, and the gas emerging from the cold end can reach -50. Okay, so it's unsurprising that there would be temperature differentials. Okay, And this was, identified as a potential thing that might be going on by Chiropolis in the Pantone GEET system. Okay, so what I might suggest is the simple cone, truncated cone, and maybe this end is drilled. What might be more perfect is what nature is telling us is the right thing, which is this cone with this pit with a cone in it and a cone with a pit in it, because this helps force the vortex. Okay, but essentially, sometimes in ultra experiments, it really does look like a cone and a pit. And to be exactly what we need to be, we can run some experiments with the ultra experiment, and maybe the actual angle on here we can learn is the best angle that one might expect for this cone to be in our tube here. But I don't think it's that important. I think maybe this is going on. We're getting potentially up to 200 degrees C from ambient temperature stuff coming in here. That at 200 degrees C is going to start to break down stuff. Now, it doesn't just end here. We're not taking the hot air here. It's having to force itself down this side of this chamber, okay? And this is a piece of computational fluid dynamics. It's done in a piece of software called ANSYS Fluent. And you can go and look at this video here. Now, this is something that if someone's interested, I would be very pleased to see them do a computational fluid dynamic simulation of what is going on. Oh, I've given the game away there. Here and here at the depressurization and the kind of like pressurization heating end. Okay, right? So if we are creating a high temperature here and it's coming here, and the cool air is coming down here, what you've got is if we have created some charge separation, which you'll see in a minute, and it's in vortexes, and we do get some coherent matter, or it gets so hot that it breaks the material down into its individual atoms and ions, it almost doesn't matter what you have in your alternative fuel, right? As long as you are within a parameter space, and I'll tell you what that is. But as we know, if we have clusters, because of the vortex nature coming down here, they are going to create an intense pressure, and that's going to force out thermal energy, and that's going to go into the gas out here. So you can kind of get an idea of where I'm going. And if it gets completely coherent, then you are going to have electrons condensing, and they are going to shift out energy. And at this end, you're going to have charge clusters, and suddenly it comes into a depressurization zone. And, they get relaxed and so forth. And, what's also similar here is let's say if we've generated 200 degrees and the hot gas is coming in here and so forth, the Tesla's electric particles of matter actually used steam, dry steam. And if you had some water in here coming through here, you would imagine if it was at 200 degrees centigrade and it was at high pressure, that would maybe be at the point of dry steam. Dry steam coming down the side of here is exactly what Tesla had in his 1930s drawing of the electric particles of matter gun, where he had dry steam coming down, producing an open-ended vacuum tube. So this does produce a vacuum here. And when you have a good vacuum, you can get lower energy of electrons, will enable ionization of the small amount of residual atoms in this zone that will allow for ionization. Okay, so what you've got is potential electrostatic or emission of photons or whatever. As this depressurization occurs, this vacuum is occurring here, you start to get ionization in here, then the ionization then starts to self-organize and so on. And it's not surprising, therefore, to me that you would see a ball lightning sort of analog forming at this point. And when we know we have ball lightning, what we know is that the double layer, the coherent matter layer, which we have shown in tungsten chop shop and other Vega experiments relating back to other work that was done in 2000s and before, early 2000s and before, that on that boundary layer, on the outside to the inside of the boundary layer, it's interacting with matter, as we saw in the copper in the ball, like 10 millimeter or 15 millimeter ball lightning cut, where you see those tubes, those flux tubes cut out of the copper. And in the inner layer, it's perfectly coherent. And that between those two is where you will have transmutation. But you will have clusters coming through here replete. These were many clusters. And it comes through in the engine. And if you have a spark plug in there, then the spark plug will effectively be doing, effectively what you've got here is a kind of PAP engine. The rod and the turbulence and the charge separation and the forming of vortexes, streets forming into clusters, and that depressurization and that ionization, creating that ball lightning. We know from the work of Oroitskiev, when a ball lightning disintegrates, it produces micro ball lightning, self-similar. Okay, we know that when we put the HHO, the Amarza gas, on the 10 yen coin, it produced a big coherent matter cluster. Then off to the side, orthogonal to the boundary of the coherent matter structure, was another coherent matter structure which had on zinc on one side, predominantly non-spin atoms, and copper on the other side, except for the spin ratio of the zinc on this side, and on that side it had all spin atoms of copper on this side. So the non-spin atoms are left over here, the spin over there from the center of the vortex is pulling the spin matter through it, dumping it down here. But when the ball lightning died on that self-similar subquanta, it left small micro ball lightning that moved around on the surface of that copper, sucking up the copper oxide, living possibly for days, like was observed by Bogdanovich et al., and fusing the 2 oxygen to sulfur 32, something that's observed as a product of ball lightning when it explodes. Okay, oxygen. Now, in that environment, the micro ball lightning has oxygen, nitrogen in the air, argon in the air principally, and copper. And the concept I've had for many years, which I shared very clearly at 2019, is that this system likes to fit things into a small box. It's a compressive technology. And the thing that will allow it to give the most compression in any given time is the thing that yields the most energy, because energy in any sense is the difference in distortion of space-time. Okay, so if you compress, if you've got a selection of atoms that you can compress and you have a certain amount of time to do it in, the thing that allows you the easiest compression, like the squidgiest foam out of all the foams you've got to make your mattresses from, that will fall the most first, right? So if you have a system where you only have oxygen, nitrogen, and so on, but the oxygen's right there on the conductive surface of the copper, that is basically, you've got copper and you've got oxygen. So the ball lightning is going to want to fuse that oxygen and oxygen together. It's the easiest thing it can do because it gets the biggest squash out of fitting something into a small box. But what, for instance, if you had hydrogen, carbon, and oxygen? What would be the outcomes if you had hydrogen, carbon, and oxygen? Well, I think we all know that per nucleon, the most energy you can get from fusing matter is like a deuteron and a deuteron fusing to helium, or a proton and a triton fusing to helium, or proton, 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 proton fusing to helium. That whole package of things is the most energy you're going to get out of squeezing things into a small box. The most energy is the most change in the distortion of space-time. Okay, so that is the thing that will happen first. Now, you've got carbon, you've got oxygen. Well, the crust is 52% oxygen. So we know, if we assume that the crust is 4.5 billion years of evidence of Lena at work, we know that it really, really, really likes to produce oxygen more than anything else, okay? So O2 is the most thing. Now, if you've got carbon and you've got helium, well, what does LENR do? Well, it does alpha conjugate nuclei. It'll grab that helium in a scenario where you have carbon, which is a non-spin matter, okay? It's non-spin and nuclei, and you have a non-spin nuclei in the helium, and you fuse those, let's say, on the exotic vacuum object's outside sheath, which is coherent superfluid superconducting electrons, which shield the charge of the electrons. So there's no Coulomb barrier. It comes into that superfluid superconducting condensate, and you get the nuclei fusing together. And the thing that will give you the most gain in space-time, i.e. the most energy output, the thing that's most likely to occur next after you've fused your hydrogens to your helium, the next thing that's most likely to happen is to take helium and fuse that to carbon and get oxygen. Okay, so with that in mind, so we know we're creating heat here. It's over the boiling temperature of water. We know we're going to get hot zone here. And interestingly, you get a hot zone at the end. And you're not seeing that because I'm not showing you. So in this simulation, so what I'm asking someone to do, if they would like to do it, you can get a free trial. And I would like someone to take the proportions off the Tesla Tech site or off Rex Research for the inner, outer and whatever diameter of this system, and do the CFD for this end and this end for a particular flow rate coming in here, so that we can work out what kind of temperatures we might be achieving. Now this is a bullet traveling at a very high temperature, but you know, it's not constrained, okay, and it's not cone, and it's not a pit here, but we have hot here and we have hot here. I imagine that the vortex nature will be slightly different at either end, and so on. Now, what happens when you have charge separation in turbulence? So what happens when you have turbulence is you get charge separation. And this paper is from 2018, and you can go and see it in Nature Communications. I've given the link here and the Sci-Hub link here for the full paper. And it says that if you have negatively charged particle cloud here, you get negatives, predominantly negative in the middle, you get negative repelled, and you get positive ions pulled in, okay? And in this case, you have a positively charged particle cloud. Here, it's repelling your positive structures here and pulling the electrons in. This is kind of what's being said by Paul Pantone. It's pulling in electrons from a distance. So can we assume that we have a virtual anode being produced? What would produce a virtual anode? Well, I think we've talked about that in the past. Okay, so is one side producing a virtual anode and the other one producing a virtual cathode? Well, actually what Paul Pantone describes in one of his videos, and in fact several of his videos, is that when he built a glass reactor here, he was getting arcs between the ball at this end and the other end. So there would be a nature of a vortex at one end that's forcing maybe positive charges out, and then the other one is pulling negative charges in. Okay, so there would be a discharge from one end to the other. He argues that this doesn't ignite gasoline because it's in a very low pressure environment, and in fact by the time you get down to here, it's probably not gasoline anymore. It's completely fracked, and it's in its atomic or low molecular states. Okay, so and that's not important, because the important thing is to capture certain molecules and atoms in the ball lightning, cohere it into cluster. When the cluster breaks up, which it will be continually doing because you've got so much dynamism going on here, these clusters will be pulled through here, and then you end up with a kind of hydrocarbon version of the PAP engine. So what PAP was doing is he was using, and I've described this well in my monopole clutch Russian conference presentation from a number of years ago. He used either cathode ray tube, or he used a radioactive source, and we know that produces these charge clusters from the work of Shishkin et al. Since 2009. So you have the radioactive samples, and John Hutchison used this as well. They produce ionization and charge clusters, and the clusters aggregate in the PAP engine, and then he discharges that, blows up the clusters. When the clusters are forming, they release heat. Okay, when they are being blown up, they capture heat back in, and essentially you have this plasmatic expansion process. The reason it expands is because you've got Coulombic explosion. That shockwave goes up, but then as the atoms reform, it produces an intense vacuum and pulls it down. Okay, and the heat comes out when the cluster is forming, and the heat has to go back in. So it's a cold process, and you have a half toroid cylinder head that produces a toroidal vortex of charged particles that goes up the channel. This produces magnetohydrodynamic effect because you've got charged particles moving over around the outside of the torus, and this is picked up in the coil on the outside. And what was described by Paul Pantone is that when you put a coil around here, or like an ammeter around here, you get you can pick up power. And I think he said that someone actually generated quite a significant amount of power from what's going on here. And this is not unsurprising, because you have all kinds of vortex of charge separated structures here, and you also have probably ions coming this way and ions coming this way. And so there's quite a lot of opportunity here for induction and magnetohydrodynamic effects. Okay, so the problem that I identified, and why when what happened with how should we put this, when Feynman went to do the pre-test before it was going to be tested at Stanford Research International, when that was a government-sponsored outfit, mostly, like totally rather than unofficially. They had, he went along, he didn't believe it was working. There was a little thin wire going to the wall, and I argue, just like the Russian research that showed that they can transfer 25 kilowatts over an 8-micron wire, these were charge clusters that were building up in PAP's engine, and that went to ground over that small thin wire. And when Feynman pulled that out of the wall, the charge clusters started to build up in the PAP reactor, and then it got to a critical point at which it caused a fracture of the iron in the cylinder head, or metals, whatever metal, it doesn't matter, but normally ferromagnetic materials fracture, and we've seen this in Hutchison effect. And the aluminium cylinder head, let's say it's aluminium, came out, and in Feynman's own account and in no other account, a silvery, shiny blob came out and then turned to a puff of smoke. And I argue that that was not solid, but not liquid, but jellified, aluminium, that then, because of the charge clusters in it, instantaneously oxidized it en masse, and that produced aluminium oxide, and that produced this white puff of smoke. But fragments came out and killed one person and severely maimed 2 others. Okay, and eventually PAP was compensated, because it wasn't really his fault. He said, "Put it back in the wall, please." But the kind of beauty of what's going on in here is we demonstrated a number of things when we looked at a Mars gas. We showed, and it's interesting because in a couple of the videos, or one of the videos, and I gave the reference in remote view.icu, he talks about it being similar to Brown's gas, which is like oxyhydrogen gas. It's not straight stoichiometric H2O, separated. It's not that. It's much more interesting than that, and we've discussed that at length. But we showed that if you take a Mars gas and you put it on metal, it's not getting to thousands and thousands of degrees. It's not doing that. It's not thermally. There's not that thermal temperature, but it is causing disintegration of tungsten and titanium. And it was assumed that that was because of the temperature. But we showed that there was transmutation occurring on the surface, and by capturing particles coming off, into a face mask filter and looking at those particles, we saw that the particles captured, which had some tungsten with them, also had the same transmutation products as was on the tungsten. This was the first time it was done. It was done live on camera and captured, and we shared it. And so what we're showing is that the bolometer did not see the boiling point of tungsten, even the melting point of tungsten, but there was transmutation going on, okay? And David Butelier did that, and we looked at the, he replicated the system with an HHO system, and we looked at the samples, and that produced the same effect. So we've replicated that internally, and so that is verified. So it's transmutation going on. The same thing with titanium, less dramatic, but we did have this situation where we put the HHO on the titanium and the amasa gas in this case, and then it was touched to a piece of polytetrafluoroethylene. Obviously that has the wonderful fluorine, which is a spin isomer, okay? So that would get pulled in, and it had this incredible explosion, and we got this coherent matter, and we got these instantaneous production of nanocrystals with voids, which is defined by Solin as a signature of the collapse of a coherent matter structure, okay? And we shared that, okay? Now the interesting thing is, when you added 10% or more of a hydrocarbon, then it got hotter on the bolometer. Now the story with Brown's gas is it cools the temperature of the flame. Now you might consider that if it's producing UV and soft UV, UV and soft X-ray photons, okay, like up to 2 kiloelectron volts, then they are higher temperature photons. But most regular people consider temperature as IR photons, things that make you feel warm, right? Things that don't give you sunburn, right? Like, but it's the carbon that you're adding in there is downsampling that high energy photon to a thermal photon. But the interesting thing is when you put that 10% hydrocarbon containing HHO, in this case amasa gas, onto tungsten or onto, say, titanium, it did not melt it. It did not destroy it. It did, however, make it glow thermally hot, and it was hotter recorded on the bolometer than it was recorded when there was no hydrocarbon in there. So I have talked about the fact that carbon is very, very, very important. It kind of goes round in a loop. Firstly, there is the carbon cycle, where carbon acts as a CNO cycle. So the carbon-12 acts as a catalyst. You keep adding hydrogens, and it goes around from carbon to nitrogen to oxygen, and then back round to carbon, okay? And in the process of doing that, it releases, what does it release? It releases an alpha particle, okay, for helium. This is part of the way that suns work. Now, if we're arguing that the ball lightning is doing the same thing as the sun, then this is doing the same thing. If this here has a ball lightning at this end, and we have carbon coming in and we have hydrogen, we could have the CNO cycle going on in here, and we produce helium. What does he say? He produces helium, and he produces oxygen. And what is oxygen? Well, it's helium plus carbon. And they're both non-spin matter, which can both fuse on the boundary of the exotic vacuum object. Okay, so hopefully that's given you a little bit of understanding of potentially what's going on here. So let's move on. So we have the potential for producing some structures which are negatively charged EVOs, and other ones that are positively charged EVOs in charge separation. And this is the fundamental thing that Ken Shoulders says is necessary for the production of EVOs. And he saw positive, negative, and neutral structures, in fact, in his work. And so it's unsurprising what's observed. Now, if we are to look at the different fuels that were claimed to work in the system that Paul Pantone promoted. Let's look at the first one we might consider. Will be gasoline, okay? Called petrol in the UK, but of course, petrol, people think of that as maybe only a British thing. I don't know how many countries call it petrol, but anyway, gasoline, or gas for short. And this is C8H18, okay? And it has a ratio of carbon to hydrogen of 1 to 2.5, okay? Now, diesel has a ratio of 1 to 1.92, carbon 12 H23. And when you look at those two, you can understand why gasoline burns cleaner than diesel. You get a less perfect burn on here because you've got a lower ratio, okay? That's the arguments that are made. Now, Paul Pantone talks about having soda pop in there and a bit of gas and so on. Well, what have we actually got in soda pop? Well, let's have a look. In soda pop, you have water. You also have carbon dioxide, CO2. So you add an extra carbon and you've got water. But what you also have is glucose and fructose, typically in your average soda pop. And that is C6H12O6. There's a slightly different structure between glucose and fructose. Fructose is the sweeter one that you sense. But actually glucose is the predominant sugar that plants produce. Algae produce, all kinds of things to produce. Now, at this point, it's as well to remember that the powers that be want you to move from a tungsten filament light bulb that emits relic neutrino clusters that have potentially health benefits, and also UV that potentially has health benefits if it's the right type, but also thermal photons, which also have this production of EZ water. All the kinds of things that you got from the natural sun, right? Plus being able to see with the full spectrum, to LEDs, which don't produce most of those things in any meaningful amount. And now what you've got is a desire to move people to electrification of their motor transport. And what this will do is, like the move from valve systems to transistors, if we do not work out how to do this technology for ourselves now, if we do not know how to do it, the next generation will not have a chance. Why? Why? Because they won't have loads of old internal combustion engines lying around. We have the responsibility to our future man to sort this out, ensure we know whether it works or it doesn't, so that we do not lose the opportunity that's presenting itself right now. When we're all electric, it'd be like all of the ICEs have been melted down. The chance of someone with the right knowledge, the will and the wherewithal to have enough time to test this out to its logical conclusion will be lost. It is our duty. We are behoven to do this. Okay? So really, we have to work out whether Paul had something, and I really think he did. I really think he did. Okay. So, sugar in water, well, that's great. And the great thing about water is that it has H2. So adding water is not a problem. It might sound like it's going to quench a burning reaction, but we're not talking about a burning reaction, are we? When we're talking about what's going on down here, it's not a burning reaction. It is a nuclear clustering effect, okay? And it comes through here, and you get a detonation of that. There will be transmutation here. There will be release of that from a Coulombic explosion in here, and coming down. Coulombic explosions exist. We've shown them. And what happens when you have these Coulombic explosions? We've shown in the Vega Valley, one of the first two videos shared from Henk Uren's Vega Valley, is the side of the chamber was hot. You could see this glow. And when the Coulombic explosion happened, boom, it goes black. And then you can see it reach thermal equilibrium as it comes in from the outside, as the metal reaches thermal equilibrium the rest of the chamber. Okay, so when you've got a detonation in here, it's going to try and extract thermal photons from the environment around it. So you have an environment where here it might be trying to, it has a positive anode here, and it might be trying to suck in electrons from the world around it, plus some that come from down here, okay? And that's piling in electrons into the charge cluster. And remember, for every ion, it needs 100,000 electrons. So it has an incredible desire for electrons. Comes round here, the cohered electrons get blown up in here, as they did in the PAP engine. That produces a cooling effect, and it comes down here, and it's cool. So if this is cool coming down here, right, and this is getting hotter and hotter, it's like 200 degrees down here, it's getting hotter and hotter and hotter, and then this cool air comes down here, there's going to be a heat exchange between these two, and the claim by Pantone is that the exhaust comes out about the same temperature as the gas that goes in. Why? Because you have this similar to the no heat generating plasmatic exchange going on in here, and you've got an exchange between the thermal levels from one point to the other in here. Okay. All right. So let me get to the next one up here. So this is sugar. Now, what about oils? My darling wife, she has a little bistro, and she produces Vietnamese rolls. You should try them when you're in Brno. They are excellent. They are probably the best in the country. Traditional recipe. And she uses fresh sunflower oil. She could use rape, but the texture and the flavor's better with sunflower oil. And she likes to change the oil regularly. It's very shallow fried and so on, but she likes to change that oil regularly. So she produces about 3 liters of dirty oil per week, okay? So about half a liter per day of used oil. Now, that has a whole lot of hydrocarbons in it. What does it have in it? Well, carbohydrates, even type things. It's palmitic acid, stearic acid, oleic acid, and linoleic acid are the predominant ones. And you can see when you're down here, if you've got palmitic acid, you have C1632. So that's actually, the H ratio is not high. What we want is a high H ratio relative to the carbon. When we come here, it's 36 and 18. So that's like 1 to 2. Okay. This is less than 1 to 2. And this is less than 1 to 2. So stearic acid is probably really good. And if we look at palm oil, or should we say rapeseed oil rather, canola oil. This is from an animal feed website. You can go and have a look at it down here. The linoleic acid here of rapeseed oil or canola oil is 9.2%. It predominantly has oleic acid, 60.4%. So oleic acid here is not great. You know, it's less than 1 to 2. And linoleic acid here is just 9.2%. So that's 18 to 32. Now, if we look at olive oil here, oleic acid, it has up to 83% here. Okay. And it has also down here, it's got palmitic acid down here as well. So they have different oils in there, but essentially they got carbon, hydrogen, and oxygen. Okay. Now, what Paul Pantone said, that actually, if you're using some of these alternative fuels, I think I clocked him saying that sometimes you will want to add some detergent. Now, the reason you add detergent is to create an emulsion. This is where you have a detergent is something that at one end it has a hydrophilic molecule that grabs onto a water molecule, and the other end it has a molecule that's philic towards various oils and such like. And so it groups those two together with the molecule kind of holding on to them. And so you create an emulsion. Actually, Shishkin discovered his birdies, his magnetotoroelectrical radiation, when he was creating a cavitator to create an emulsion of oil and water. Why was he doing that for a client? I don't know. But anyway, he was creating an emulsion of oil and water through the cavitation process. Okay, and he produced this strange radiation. Now, if you add a little bit of detergent in there, what are you getting? Well, a detergent, for instance, here is C18, H29, sodium, oxygen, and sulfur. So we're adding another sodium atoms in here and sulfur. Okay, but predominantly, again, it's C, H, and O. Okay, so you start off with your lovely, lovely gasoline here with this 1 to 2.5 ratio, really rather nice here. Over here, you get it going, and then you have your secondary material here, which might be diesel, soda, water, glucose, fructose, and carbon dioxide, carbon, hydrogen, sodium, and oxygen, and sulfur, and even he suggests using crude oil. Now, if you get crude oil, like petroleum oil, and you mix that with water, and you mix that with a detergent, you'll end up with something that can form an emulsion, bubbling going through it, produces a vapor with entrained emulsion, and then that would go into your GEET system, and that would atomize it. And at this point, it really doesn't matter what you get in there. When it comes down to here, it's all broken up into carbon, hydrogen, oxygen, and potentially sodium and sulfur if you've got a detergent in there. That it goes for the fact if you have carbon monoxide, it goes for the fact if you've got carbon dioxide, anything. It ends up as these small molecules and ions thereof, and ions will produce these charge separation clusters, and they will produce the exotic vacuum objects, especially when you have a system that produces vortex and the thermal separation as well. Okay, so those are the kind of things that they say they would have in there. So it makes sense. It all makes logical sense. Okay, so we've got to ask ourselves, what might be best? Well, if you're looking at the fuels that are going in, we know that bosons like to interact with exotic vacuum objects. And there are spin or no spin bosons, and they're present in the GEET reactor, or a maser gas, plus a hydrocarbon, so including composite boson. So the hydrocarbon, to just go back to that point, carbon goes round in the loop, okay? However, when Tesla was developing the carbon button light bulb, he established that when you have any other element in the periodic table, the etheric matter, whatever that is, we don't need to go into what that is at the moment. Carbon was the only thing that could realistically survive. And interestingly, he said silicon as well, silicon carbide as well. Okay, so carbon is the key thing. And so it can convert this intense attack into thermal photons, which produces the incandescent light that you saw in the carbon button light bulb. Okay, so he basically looked at all the elements you could possibly imagine, and he found that essentially this etheric matter would basically destroy any other element. Carbon was the one that survives. So the carbon will protect the reactor. Just like when you added up to 10% or more of a hydrocarbon to a maser gas, it didn't destroy the tungsten. It didn't destroy the titanium. Okay? It got it thermally hotter, but it did not destroy it. Okay? So the carbon is protected. Now, he makes the claim that the GEET reactors last a lot longer. When you open up the reactor, it's not damaged, right? And this is consistent with this understanding. It's consistent, okay? So moving on. What have you got in potential fuels? Well, if you've got hydrogen molecule in there, you can have parahydrogen or orthohydrogen. And para has spin and ortho has no spin. And the way you convert from para to ortho is you go from room temperature and you cool it down to its below its boiling point. Okay, that's pretty darn cold. I think it's like 20 Kelvin or something. Okay, so it's really cold. But would it be possible if we had this pressure drop and we had these clusters, and in the center of the clusters had lost all the energy, would it be possible that by the time it got to here and went into the pressure drop and it formed part of a massive EVO, could it be possible that it was as cold as 20 Kelvin, at least in some part of the structure? Or could it be that when the explosion occurs in here, any para-hydrogen proportion in the hydrogen that comes through the instantaneous cooling, which it would appear we have shown in the Lion reactor, went to minus 273 degrees centigrade almost instantaneously, could cause the para-hydrogen to be automatically converted to the ortho-hydrogen. If that's the case, then very rapidly, if it was over here, that would be ideal. You would have the conversion of hydrogen molecule into an ortho state which has no spin, which means it can interact with a closed flux. If it's in the para state, if you had open fluxes, which you will see these systems do have in abundance, in my view, and I think I can demonstrate that absolutely with hard replicatable data, that the ends of the flux will be able to suck in the para H2. Then you have deuterons, which have spin, D2, which also has para and spin, and ortho no spin. So the same goes for the hydrogen there. There might be a slight different temperature at which it forms automatically the ortho. You have 4 helium, which is no spin, and 12 carbon, which is no spin. Okay? So you want to get a situation where you have either spin elements interacting with the end of fluxes that are, in my view, the end of fluxes are in the outer part of the double there. The fully coherent part of the inside of the double there is a closed fluxes, right? They are proper fractal EVOs, okay? But in both cases, on the outside of the fluxes and on the closed fluxes, you will have a fluidized electrons, as said Kin shoulders, and these are superfluid and superconducting, and they perform interactions with non-spin nuclei. Okay, and then you have this situation where you can have H star. And what do I mean by H star? Well, it's not a proton in its own, and it's not H minus, which is a proton with 2 electrons. Okay, this is a proton and an electron. Okay, so this is atomic hydrogen, and this can have a spin of 0 or 1 depending on the spin of the electron. Okay, so and this would be similar for deuterium. So if it has a spin of 0, the H star can interact with other for helium or with other things on the outside that are no spin, and with carbon on the outside. So if you had carbon on the outside with no spin, and H star, 4 of those on the outside, so you had 4 of those and 1 of those on the outside, you would instantaneously get a fuse potentially to 16 oxygen potentially. It's not quite right, because you need just 2 of the hydrogens to become 2 of the protons to become neutrons. Okay, but anyway, if it's got spin, it could be pulled into the end of the fluxes. Interestingly, when you have the spin flip go from up and down, that is a 21 centimeter roughly of light. And is that why in the hydrogen system, when you have a spin flip, the Proton 21 lab of SV Adamenko was called Proton 21? It just might be. Right. Again, what might be best? Note, Paul Pantone claimed to have observed helium and excess oxygen in the output. Paul Pantone claimed to have observed helium and excess oxygen. Now, helium shouldn't be in there. If helium's there at all, we are talking the same process as Lena. We know that Lena likes to produce helium. Okay? And we know that Lena, if we look at the Earth, as I said earlier, the crust being the best record of Lena processes for 4.5 billion years, that has 52% oxygen. Okay? It's an outcome that nature wants to produce. The carbon cycle, basically the stars burn the protons to carbon, and then the carbon cycle goes around in a loop and it produces helium. And so on. We have those systems that are taking place in the sun, and oxygen is this abundant thing on Earth. Okay, so it's not surprising that when you have a system that can use this process, it's not surprising that you would see helium out and you would see oxygen, excess oxygen out. What I would also expect is you would see a depletion in the atoms of carbon. That would be coincident with the increase in oxygen out. Okay, so if you take a hydrogen and a hydrogen plus a electron and a cold antineutrino, which is a form of dark matter, and you had a toroidal moment structure that could bring these things together towards a superfluid superconducting condensate, you would end up with a deuteron being formed, and this gives you 1.441955 mega electron volts. If you had two deuterons formed in such a way, and they are in a state where either they're going into the end of the flux tube because they're in a spin state 1, or they're at 0, they're going into the side of the exotic vacuum object of whatever type it is, then that goes to 4 helium, and this yields 23.8472 mega electron volts. And if you have 4 helium around and carbon, and you fuse those together, you get 16 oxygen, and this gives you 7.1613 mega electron volts. The above reactions leads to a total of 32.450455 million electron volts. And if you do the calculation, because it's roughly about 5 electron volts for the formation of carbon dioxide from the burning of carbon and 2 oxygen, this is 6.5 million times more yield, taking 4 protons and fusing 4 protons and a carbon into 16 oxygen. It's 6.5 million times more yield than you get from producing CO2 from burning carbon and 2 oxygens. Okay? Right. So what, therefore, in the world, in the entire universe of elements that we would want in a reactor in abundance, and what would be the absolute best fuel you can use? Well, I would argue, my friends, that it is methane, because it has an exact 1:4 ratio. Okay? And it doesn't matter if you are directly producing the oxygen from a carbon with the 4 hydrogens around it, like we see here in the molecule. We have carbon here with the 4 hydrogens around it. If that entire thing collapses into oxygen because it's methane, then this is a perfect ratio to convert from one to the other, okay, in my view. And it could be the case that, like in a fractionation column, a fracking tower, as long chain hydrocarbons are coming down here, we effectively have a fracking system, a fractionation system in here, where it's a reforming system. So it's methane reformation. You're starting with longer chain hydrogen molecules here, longer chain hydrocarbons here, and you're adding a bit of water, and the combination between the water and the hydrocarbons is doing hydrogen reforming in here, or whatever. It's doing this production of shorter chain hydrocarbons, and you might actually get methane synthesized from longer chain hydrocarbons in here. Really, it doesn't really matter, because the ball lightning at the end here will sort it all out. And if it's there, it's there. And this is something that we hope to be able to verify. And I'm pleased to say that David Boutillier and Henk, they're both working full time. It's tough to do this. But David's already been to the hardware store and is already part of the way through making his GEET. He's got an old lawnmower that he can attach it to, and he's put in a viewing port in there to see if we can see the plasma going on. If we can create some GEET processed rods, we will look at those. Unfortunately, the company that I was renting the SEM off last year, they do not have any in stock. And the wait time for them, the earliest that you could buy one if you had all the money in the bank right now, would be at the end of this year, in November this year. So we can't rent or buy one, even if we had the money right now. So we're not going to get access to that large format table. However, we can chop up the samples, and if we degauss them, because SEMs they really do not like intense magnetic fields. inside them, okay? You might break them, okay? So we need to degauss them. And fortunately, Alan, because he was in tape recording in his Magic Sound Lab, he actually has a device called a degausser, right? And it's like you put your magnetic tapes in there and you go like this, and it demagnetizes it. So hopefully that will be able to remove any traces of these magnetic clusters that are obviously aggregating in these structures. We know when ball lightning exploded in the work of Voroitskiev et al. In the early 2000s, when that exploded, it shot out structures that were collected by iron 57 plates with a north behind it and another one at a different place with a south behind it, and that changed the magnetic fine moment or whatever of the iron 57. And so we know that it aggregated in there for a period of time. We know charge clusters can persist in materials, particularly metals, for an indefinite amount of time, according to Ken Shoulders, and certainly there's evidence of that in other places. So it's unsurprising that you have these magnetic anomalies. I think it's something like a paramagnetic, diamagnetic twin pole that's caused by the exotic vacuum objects at either end, and I think when we get some GEET samples we'll be able to verify why a magnetic compass is affected in the way it is, as you see on the videos, which is like, oh, but actually I don't think it's going to be that hard to solve that. And you know, the concept of why it's happening, I think we can verify fairly readily once we have a rod to be able to analyze. Okay, so that being said, so this is the perfect thing here. And the beauty of this is that you can produce this with biogas reactors. And if you get a good biogas, my brother actually worked on a refuse site near us where I lived in the UK. And what they did is they covered it over with a membrane, they covered it over with soil, reclaimed the land so it all looked lovely and it's got nice pasture or whatever it is on it. But what they did is through the waste tip, they put loads of pipes, and then they had something that gathered this anaerobically produced gas and it went into a turbine and it produced electricity. So rather than the refuse site belching out methane for hundreds of years, damaging the environment, it was actually producing energy from capturing and burning and going through a turbine and whatever energy. So that's one way. When I was living in India, my friend who set up a business after me and very successful actually, he had a house nearby and he got a bioreactor installed there, and it was actually fairly large. And what you did is you just put all your food waste in there and any kind of rubbish within parameter space in there, and it was anaerobic. Obviously the weather in Kerala is absolutely perfect for this. It's kind of like typical daytime temperatures around about 30 degrees. The at nighttime temperature never drops below 24 degrees. So the average kind of temperature in the soil is typically between day and night throughout the whole year is about 27, 28 degrees. So it's absolutely perfect for this. And they would produce all of the biogas they needed to do all their cooking in their house. Okay, but imagine if the biogas was being fed into this reactor and it was actually giving a yield that was anywhere close to being 6.5 million times more yield. And it would not surprise me that if you got just a few atoms, either being converted in a nuclear sense or total matter collapse into light and electrons, or photons and leptons, that you could have a system where you could actually close it. You could close this valve off, the gas would come out here, go in here, or suck in the other material here, and you would end up with a situation where it is claimed by Roish and Amaza, a closed system, where it could go round and essentially you would only need a bunch of atoms to change in every one cycle. You would have all the energy to just keep on running. But let's say you could never get to that level of efficiency. I'd be very, very happy, running my household on the filtered waste oil of my wife's business with a little bit of detergent and some tap water, and having a generator producing electricity day in, day out for all our family needs. That would be absolutely wonderful. But if you didn't have that and you had the opportunity to go and produce biogas, then you could really, it's the perfect molecule. And it's saying here that, you know, you can get up to like 75% methane, but what is the rest of it? What is the rest of it? Well, the rest of it is at least 15% CO2. Well, we're not worried about this, and I'll tell you why. Oxygen is not going to play a role. It's not going to play a role. It's just a bystander. It holds molecules together. Nitrogen, well, that can be 0, so we don't need to worry about that. Hydrogen, well, that would be good if we had that. It can be 0 to 1, that's fine. Hydrogen sulfide, that's okay if it's 0, not so bad even if it's 0.5. The reason is that sulfur, and the reason is that oxygen, is that fusion with sulfur and oxygen or nucleon exchange reactions do not exceed the reactions with carbon. They do not exceed the reactions to produce helium. They do not better the output from fusion of those other molecules. And this was talked about by Leclerc, who we mentioned earlier, which is a similar based system when you think about it, a little bit tangentially. He said that you needed, it was a threshold of about 55% carbon. And when you went through that threshold, you then started synthesizing heavier elements. But in our system, in this system that we're talking about here, our system that we're talking about today, you're always going to have, ideally, a lot of extra hydrogen in there. And all the time there's hydrogen in there, it's going to keep that down, working from the carbon towards the oxygen. It's not going to be pushing it beyond the oxygen, okay? Remember what I said, when the micro ball lightning fell off the macro cluster on the 10 yen coin, which was exposed to the Amasa gas, it had copper and oxygen. So the thing that it could get the best yield from, when it was trying to pack things into a small box, is oxygen. I'm going to demonstrate that using the Philip Power Martin Fleischmann Memorial Project Lena reaction tables at nanosoft.co.nz that used the reaction tables produced by Dr. Alexander Parkhomov. We can show that if we assume it's fitting it into a small box, it will not be outputting heavier things if it has plenty of carbon and hydrogen in play. And you want an abundance of hydrogen. Okay. I will in a separate presentation, it was one thing that I was going to do before we started talking about this or thinking about this. I will talk about how it's harvesting material from the far field, but I'll give you a little teaser here. We know that coherent matter, which this has, we know that in the Lockheed Martin awarded patent, they are saying that coherent matter, which they are saying they are creating from electrons, right, can enable single bath thermal extraction. And I can tell you it will allow single bath thermal dumping, but extraction is more what's interesting here, okay? We have shown you all of the evidence over the last 6 years, so you know this can occur. You know absolute 100% with the evidence you've already been shown that this has been physically demonstrated by the MFMP, it's been physically demonstrated by Russians and in observational terms and so forth. And you will know that this is possible. It has scary, scary implications. And because it has scary, scary implications, it is more important that we talk about this first. Once you have abundant, low-cost, clean energy, everything else becomes possible. And all of this nonsense about global warming. I mean, we're killing two birds with one stone. Literally, you're killing the excuse for getting rid of cows. You're getting rid of the excuse for global warming taxes and this, that, and the other, and the excuse even for electrification. If artificial intelligence is going to kill a load of jobs and people are happy to move ahead with that, then let's deal with the energy industry. Let's give them this option. Let's see if this can be realized. Okay, that's what I'm calling for here. That's what I'm calling for. We need to move to the next level this year, working together. We're not talking about a few milliwatts here, a few tens of watts here. We're talking about systems that exist all over the world. And if we get this right, we can implement ball lightning. Remember what was said by the US Air Force in their 1994-5 paper in fusion technology. If you create a 10mm ball lightning, it can produce all of the energy for a home. 10mm. What's the chances we can easily produce a 10mm ball lightning in here? I can tell you, we've already done it, 15mm in Vega experiments, verified. That is what Henk Uren produced. We saw it on camera and we saw the damage it did, and it's consistent with ball lightning. Okay, so they are arguing that 10mm will do it. If this is producing 10mm or even anywhere close to it, that is going to be able to give you all of the energy, if it's done right, for a domestic home. Okay, all right. So and so what I'm saying right now is the perfect molecule, in my view, is methane. You can produce it by waste, right? You can use waste. But it doesn't necessarily need to be methane. If you want to up the amount, because oxygen plays a bystander role, you can use water, because the oxygen, when the molecule is broken up, it's just the hydrogen you're interested in. The oxygen won't play a role. It'll just come out as either something synthesized, or it will come out as a bystander to the reaction. Okay? Now, oxygen itself may play a role in aggregating the clusters. As I've said, O2 is paramagnetic. It's uniquely paramagnetic. And if it's cold, it's even more paramagnetic. And that will aggregate the monopole structures. Okay? And that may very well be important. So it may be just playing a sort of pseudo-catalytic role in this process. But for whatever reason, adding oxygen is not going to cut the reaction down, and you'll have more of it out at the end. It's the hydrogen you want. So effectively, when you have a ratio here of 1 to 2, you then want to add a certain amount of water to bump that up, okay, to try and get to your CH4. If you're starting with, how should we put this? If you're starting with gasoline, this wonderful, wonderful molecule that nature gave us, C8H18, absolutely wonderful. It has a 1 to 2.5 ratio. You don't need so much water added. And it must seem crazy to say, I'm going to add water into my fuel mixture to come into my reactor, but it's because the fuel in the patent, in his patent, it's a fuel pre-processing technology. As it comes along here, the fuel is pre-processed. It's split down into atoms and molecules and so on. It's clustered here. The clusters break off. They come in here. They're detonated. You get the plasmatic, how should we put this? The coulombic explosion, the expansion in the vessel, the cooling of the reactor. The cool things comes down here. The hot stuff's going in here. The hot gives the heat to the cool. It comes out in here, and it's basically at similar temperature. That is the claim to what's coming in here. Okay, so what I am saying is, can we run the world on cow farts? I think we can, my friends. I think we can run the world on cow farts. And with that, I'm going to take your questions. Once I've taken your questions, I'm going to go and show you, don't let me get away with not showing you, that the reactions that are possible with C, H and O are more favourable forming oxygen from carbon and helium, and more favourable from forming helium. In fact, you have to go over the helium threshold before you are going to have another reaction. Okay, so the oxygen really doesn't get a play in the game in terms of going on further. Okay, so I'm going to look and see if you've said anything you want a question answered to. What I want people to do is to go through all the videos you can find of Paul Pantone. I've said this on remoteview.icu, and try and find a phenomenon that needs to explain. I've already mentally explained most of them that I've come across relatively trivially. and of course it may be wrong, and we may find out there's some nuances down the line. But this is LENR. It is the same as HHO. It is the same as ball lightning. We have replicated the basic process. It's been replicated by Leclerc in its own way, and so on. It is charge separation. It's turbulence leading to self-organization. It is probably very likely pulling in electrons from the environment. It's also probably very likely spilling out thermal energy and then pulling back in. It's probably very likely also doing some very weird kind of single bar thermal extraction. Okay. Do you believe this is from Felix Audet, do you believe there's transmutation involved with GEET? Yes, I do. If you are getting helium out of petrol, there's transmutation. That's it. There is transmutation. That is all you need to know. But he's also saying you're getting excess oxygen. And the most likely reactions that are predicted from the Parkhomov reaction tables, the MFMP system developed with Philip Power in New Zealand, they predict production of helium, and they also predict oxygen, and those are the two things that he claims he observes. I will tell you, I will expect to see certain damage marks, which we've all seen, know and love, on the rod at either end. And when I looked at David Pantone holding up the rod in a recent video, which sparked thinking in this area, I noticed that there looked like sort of cavitation marks on either end. And I think I can pretty much safely know what they look like under an SEM. Okay? I think if we replace, and this is an interesting exercise and I would like it to be looked at, the rod with brass or the rod with copper, but particularly with copper. I think if we replace it with copper, we will see, at least in some instances, I predict, on the convex side, the same kind of tube-like damage, non-thermal damage to the copper that we witnessed on the ball lightning cut, 50mm ball lightning cut on Henk Uren's ball lightning 50mm cut video that we showed on the SEM. It's the same thing. You will see that. I'm pretty confident. And therefore, it will be 100% certain, without a shadow of a doubt, this is ball lightning, it is doing transmutation, and it is coherent matter superfluid superconducting structures. Okay? So, yes, it is doing that. Okay. Hey Bob, do you want a video of working Pantone generator or a live? I should be done soon. Fantastic WP for truth. Yes, that would be brilliant. The most important thing for us right now is to get a selection of different materials of the rods. So I would like a glass rod, I would like a brass rod, a copper rod, a steel and an iron rod, preferably, in any selection of those. And then I would like to macrophotography and ideally microscopy, and ideally probably, because I don't really want to put it in SEM at this stage, I would like to do some studies with a confocal laser microscope to see what is going on the ends of those rods. I would like to map the magnetic field on there. I do believe that there is an interaction between a magnetic compass and a para and diamagnetic structure formed by the exotic vacuum object that will be forming at either end from the charge separation. So yes, that would be absolutely fantastic, WP for truth. Corky just looked back at all going before the show. Wilhelm Reich might have had this in one form. The cloud busting. So cloud busting is quite simple. What you have is a load of tubes. The tubes have resonant modes across them, but resonant modes along them. And because they're all the same length, it produces a coherent matter wave, which is in tune to the water you put in. The coherent matter wave goes up into the sky. It interacts with water moisture in the air, and you get your cloud busting. It's reasonably well described by a Russian guy, but it is a coherent matter wave. Anyway, it's a far field projection of that. So yeah, it's relatively simple to understand that. The same things are going on in like temperature regulation, say in a hornet's nest, and you can actually produce things with straws. You can get straws, and they have a similar coherent matter wave effect. So if you get large numbers of, like, what I'm saying is like straws for how should we put this? Like from wheat, yeah? You get the straws, cut them all the same length, make sure they got nice butt lengths and so on. So you can get that. Because cellulose is piezoelectric and stuff. So anyway, there we go. That's enough of that. I'll do that kind of thing in another presentation. All right. Ema Ashura, great to have you. Cows don't fart methane; they burp methane. Well, actually, it's part and the other. There's a lot of burping, and I talked about this earlier on. They burp and they fart, so it's a combination of the both. So yeah. Certainly, when I fart, I produce methane. So at least in part. So there is actually a company that's considering capturing the methane that comes off either end. And oh my God, I don't think that's going to be very nice for the cows, to be perfectly honest. But if there was a way to do that, and we captured this beautiful, precious resource, and we found a way of doing this 15, whatever it was, it is, how should we put it? It's 6.5 million times more yield from that fusion of 4 hydrogen and oxygen to, for 4 hydrogen and carbon to oxygen than you get from carbon and oxygen making carbon dioxide. That would be awesome. So increase the dielectric value. Yeah, anything that you know, these things can be relatively easily done. So Felix is talking about the increasing the dielectric value. Yeah, obviously, if you had a quartz cylinder, that would increase the dielectric value and the charge separation going on there. So very worth considering. I think we want to do the basics first and verify that you get the plasma. I expect it's there. It's almost certain to be there because we have seen this in a series of Vega experiments. It's a long series of Vega experiments. It produced a ball lightning that was stable in a number of experiments in Henk Uren's experiments for about 2 seconds, and then it broke away from its umbilical cord, and you can see it periodically hitting into the quartz sheath. And when I showed you beautiful, incredibly highly detailed images of that charge cluster hitting the sheath, it has the structure that is the same structure that we know has got these flux tubes in it, and this will all be so clear, it will be painfully obvious what's going on. Okay. And that's now been replicated by a third party that has published their work. So we know this works, and it is due to, you know, this ability of a highly charged environment with a self-creating low-pressure environment in that highly charged environment, allowing for easier ionization and self-clustering, leading to formation of what you need for this process. Right. Okay, so okay, Felix, you need to heat to do it conventionally. Okay, I repeat my request for everyone to get the video from the GEET Plasma in Action video. Should prove it all, in my opinion. Okay, thanks, David. Felix, how about a quartz tube GEET? Yes, that's that's right. So someone has done. He did glass, but I think quartz is the right approach to that. The high-speed vortex reaches supersonic speeds and condenses heat on the spot. Condenses heat on the spot. Okay. Oh right, okay. So when it comes out and depressurizes, okay, right. Is the video from the Free Energy Interest Group YouTube channel? Okay, so that's a question from Josh, not to me. Hello, Baroness Hutchison. It's great to have you here. Nancy Lazarian channel, the power units were uploaded. Brilliant. I look forward to seeing that. Corky Goss, low key condensed matter wave works for me. Okay, right, fine. I'm inspired to build a fartmobile. Great. Well, I mean, just any scrap lawnmower. Take yourself down to your favorite scrap merchant, Baroness, and you might be able to create. See, the PAP engine needs to be carefully engineered. It ideally has a radioactive source, like you used, John, in your work, and this will produce the charge clusters. He also used a gliding arc, which I know you've used as well, and these will all produce charge clusters. But the problem with the PAP engine was exemplified by that accident with Feynman there, with the military there. And this is because of the build-up of the charge clusters emitted from the breakdown, the microball lightning and the monopoles from the overall process. And if you don't drain it, it will damage. Now, actually, there is claims by Paul Pantone that the rods themselves can cause damage to, when they're out of the reactor, they can cause damage to electronics, to magnetic recording devices, and so on. And I have no reason to think that that is not a true thing. Okay, so people need to be aware, because we know charge clusters will do this, and we know that the fields will interact in weird ways with electronics, and so that needs to be aware. And he says when the reactor is running, it will produce some sort of magnetic field, and I agree that might be the case, but it might actually be, I think, a toroidal moment. I think what's coming out of those devices is a whole bunch of toroidal moments, and that is part of how they are able to work and bring in the dark matter necessary to do those transmutations from the hydrogen through to the deuterons. And so it will be having that pull effect on the environment, and that will damage electronics. And so we need to look into that. The recent work, I will go into more detail about the recent work of the psychic in Russia that was re-evaluated in the light of our understanding of strange radiation and torsion fields, with the work of, by Vladislav Zhigulov, which I published earlier this week. And he shared some very interesting slides, and I'm going to talk about those in an up and coming presentation, and how that fits in with exotic vacuum object charging sites. But he thinks it's coming out of the reactor. I suspect that is a mark of things going into the reactor, and we already have evidence from a number of things. Okay, so right. Okay, so yeah, there's plenty of methane hydrate, methane hydrate at the bottom of the scene. Yeah. Thanks, Mr. Hutchison. Sorry, Baroness Hutchison. Fart plane. Yes, let's have a fart plane. Why not? Right, so Gordon said, I changed my Google email and managed to lose all of my old comments in the process. Oh, that's terrible. But I tell you what, if you've commented on email, then the comments come to the channel, and so I have a record of those. So maybe I can find a way to give those back to you, because you made some incredibly good comments. Intense magnetic fields will polarize light. Then, you know, this is what's going on when the self-organized superfluid superconducting electron clusters in the floodplain of the Vega Valley that you see behind me, but somewhere over there, not on the bit that's there. If you remember, we had those red and green polarized areas, both on the Dynalite microscope and on the Sony images. And that is because you've got it spinning one way in one case and spinning the other way in the other case. And they form this vortex grid, as predicted in the 1860s, I think, by Clerk Maxwell. The gas will be magnetic. So like I'm saying, is like the oxygen that will be in there, that's kind of like a bystander. It doesn't get really involved in the reaction, other than it will be the aggregation point for the monopole clusters that come out. Okay, so it might be the carrier gas for this thing. So one test I would like to do is to capture the oxygen-rich air that comes out of the reactor, and then put it into a low-pressure tube, ionize it, and see what the spectrum is. And I suspect the spectrum won't be quite the same as the oxygen that comes from the air, or the oxygen that's in the molecules that are in the reactor as food, right? So I would expect the same kind of thing occurring to a degree that is occurring when you have the Chernobyl effect, or when you have earthquake lights, or when you have these auroral phenomena. So essentially, when you had Chernobyl, for instance, you had a lot of charge clusters going in and binding to the paramagnetic oxygen, and this resulted in the change in the spectral lines of oxygen. So that for me would be a relatively easy test for someone doing this. It would be an easy scientific paper, and it would be groundbreaking, and it would be absolute proof of two things. One, that monopoles are being produced in this system, and two, that it would support the claims by Rootskeff and so on that caused the weird glow above Chernobyl, which is not Cherenkov radiation, and it was witnessed by thousands of people. Okay. So yes, magnetic gas, Felix, like magna gas. Uh, it behaves somewhat in the same as methane. Don't know. Are you talking about magna gas? Justin, I am also working on underwater plasma experiment that I think will prove more fruitful than GEET apparatus. I need help with development of strange radiation detector. I think so. The strange radiation detector, I think probably the easiest one you might be able to get away with is a reverse bias diode. Another one might be some scintillator, but that might get expensive. You might be able to create a strontium illuminate europium doped substance. I'll talk about that in another presentation. There are a range of things. The point about GEET is it brings together a large number of concepts that we've been talking about over the last couple of years. The claims that are made for it are consistent with the things that we can replicate in various systems, and it's easy to retrofit for people who, if you can go down and buy an old Trabant here in Eastern Europe and retrofit that so it runs forever and a day on your household waste oil, then that would be rather special, I think. Yeah, so that's interesting, Josh. I like the concept, yes. Yeah, so David says there's two slam dunk things here, easy to observe. The weird field from the rod, yes, and the a quality video of the plasma in action, and that is the real money shot. And I would be willing to find a way, possibly, to come and see you and bring to bear, at a distance, mind you, because it will total equipment, at a distance, mind you, a real detailed look at what's going on with that plasma at high spatial and time resolution. But anything's going to be better than what's in the public domain already. So, but I would try with well, if you want to sacrifice your phone, then maybe, but I would try with a burner phone to start with. Yeah, even if it's not the toroidal moment causing it, there will be a toroidal moment going on in the system, whether you like it or not. It's going to be there. So I really think it's probably involved. Oh, so Cosmic says, thanks for a new understanding of geek. Actually, I'm scratching the surface here. There's a lot more, but I kind of have to do some of the things that I wanted to do presentations on that I kind of got a little bit distracted in January. I won't go into it, but anyway. There are things that are contextual that need to be said, so that certain things are so obvious is that, yes, this is how it works. And I have to say, thank you to David Boudlier, thank you to Henk Ewan, thank you to Alan Goldwater, to all of the people that are openly sharing their work and putting it out there for public scrutiny. Because what was done with Vega is such a watershed in understanding so many aspects of these systems. It's literally transformational. Cannot be overstated. And so when it's like, I looked at GEET so many years ago, and it's like, oh God, you know, someone who's trying to make money from, you know, selling courses in something that may or may not work, and they can always blame the person that didn't build it right. And so there's always a get out clause. And so I didn't think too much of it. And of course, back then I'd not got to ball lightning. I'd not got to understanding that yes, transmutation can really happen, and there's a process that can happen, and blah 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 blah. We're now in a situation where the claims that he's making, which seemed extraordinary when I looked at them the first time, now seem, you know, just aspects of what should happen and what should be expected to happen. Okay, so I think I'm going to go back to demonstrating for you how we can use the... I'm listening to myself somehow here, so let me kill that. How you can use the Philip Power nanosoft.co.nz to show how it doesn't matter whether you've got hydrogen, deuterium, carbon or oxygen. There's nothing that you're going to get out of this system that is fitting things into a small box more than producing helium and oxygen from the products there. Okay, so first up, basically, if you try and fuse helium and oxygen, let's do that. Actually, we'll do the previous reaction that I was talking about, and then we'll do the other reaction. So let me start with the previous reaction, which is 4 helium and 12 carbon. And we'll just do this on the fly so you can see it working. So give me a second, and we will go do this. So if you want to do this along with me, I will make it a little bit bigger so it's a little bit easier for you to see. Okay, maybe we can work with that. Okay, hopefully you can see that. So we want to go to our fusion reactions. Here, fusion reactions. And we are going to want to fuse hydrogen, deuterium, they're already there. We put another common, and we're going to put in, well, actually, no, at this stage we're going to do helium is our small atom, which you put into element 1. And in element 2, we're going to put carbon. Okay. And we're going to execute that query. And in theory, it's going to give us the answer. Right. So basically, we're going to be looking at helium 4. Okay. Sorry. Yeah. Helium 4. So let's, it's not going to be producing helium 3 really. So I'm going to produce a boson only. So that's going to exclude the helium 3 in the reactions. And basically carbon is essentially mostly carbon 12. And if you take helium 4 and you fuse that with carbon 12, like I said, this is a boson and it's non-spin. This is a boson, it's a non-spin. Those will react on the outside of an exotic vacuum object of whatever type. This produces 7.1613 million electron volts. Okay. Now, let's say it wants to have a reaction with oxygen, because there's oxygen in the reaction again. What is that going to yield? Okay. Well, we end up with oxygen 16 is basically most of oxygen. and the helium fuses with the oxygen to give us neon 20, but that's 4.72, okay? There's hardly any oxygen 18, hardly any oxygen 17. So this is the reaction we would expect, and we are getting 4.7283, and that is a lot less desirable than this 12 carbon and 4 helium reaction here. 7.1613. So it's just not going to happen. All the time you have plenty of hydrogen, helium, or whatever, it's going to be doing that. Now, if we want to fuse two deuterons together, this is the outcome from that. So we do that. Wait. So here, this is the results. So basically you got a fusion of a deuterium, and deuterium produces helium, and there's your 23.472 million electron volts. So really, you have to exceed this energy level in any reaction. And if I look at all reactions that can kind of occur between hydrogen, carbon, oxygen here, and we put it up here, you can see that no reactions between hydrogen, carbon, and oxygen here produce more than the 23 million electron volts. And even these are, you know, even these are using rare isotopes here, oxygen 18, oxygen 18. So it's just basically not going to happen. There's always going to be deuterium and deuterium that want to fuse in this. That's actually a 2-to-2 reaction, sorry. So no 2-to-2 reaction will do it. And if we have a fusion reaction, here we go. So fusion reaction between deuterium, hydrogen, carbon, oxygen, and deuterium, hydrogen, carbon, and oxygen. So this is the expression here you want to type in. So I can go back to our fusion reaction here and do it from scratch here, fusion reactions. Okay, so there we go. So this is our expression: deuterium, hydrogen, carbon, oxygen, and deuterium, hydrogen, carbon, oxygen. We want our, that's fine. Let's execute that query, and we can see that this is the deuterium-deuterium fusion reaction producing helium-4, 23.8472. The only reactions that are higher than that are between a rare isotope of oxygen and another oxygen isotope, a rare isotope of carbon and a rare isotope of oxygen, a rare isotope of oxygen and a rare... And so basically these are... there isn't the atoms there for it to occur in any regularity. Plus, this is a boson, and this is a fermion, this is a fermion, this is a fermion, this is a fermion, and this is a fermion, and this is a fermion. Okay, so these are not going to want to happen. None of these reactions. So the first reaction that occurs is this, and it produces, this one, and it produces helium. Now, if we added into that, let's say we have, and I haven't done this, so we're just going to find this out with you real time. The elements that are in the detergent that you might need to add when you want to create an emulsion that would create entrained molecules in your entering your fuel preprocessor, your GEET. You might have sodium, which is Na, and you might have sulfur, and you might have, let's say we've got some nitrogen in there as well because we're sucking in a bit of air and that's going into the mix. So these are all our elements. So we might find a different outcome here because nitrogen there is somewhere between carbon and oxygen. But let's try and see what we get. You might all go horribly wrong here, but we're doing this live. I've not done this. So what do we get? So we've got a whole bunch of fermionic reactions and so on. And okay, so when you have sodium involved and nitrogen, you might get a couple of reactions that are above the reaction of the deuterium and deuterium. So deuterium is down here, and what we can do is say our inputs need to be boson here for a nuclear boson. So the nuclear doesn't have okay, and what else? and we want a nuclear boson here. So let's do that. Execute query. So the only reaction we could get, which has got two bosons, a couple there. So deuterium and deuterium fusing to helium, there is that one. And we have rare isotope oxygen here, rare isotope oxygen here. Okay, so nitrogen 14 and nitrogen 14 here goes to silicon 28. Okay, so there is a potential, if you've got nitrogen into the mix, that you might see silicon. And you know what? I would expect this to occur to a degree, because silicon is the second most abundant element in the Earth's crust. It's seen in ball lightning. We have proved this because we've observed it in exploding ball lightning in Henk Uren's Vega Eastern Valley plateau. And it's in the spectrum, the only spectrum recorded on Wikipedia, published in, I think, Nature or whatever, from a Chinese chance capture of the spectrum of a ball lightning. They saw silicon spectrum lines in there. And we also saw silicon being produced when we burnt HHO onto calcium carbonate in our tests with Slobodan Stankovic when we were preparing our proposal for the Fukushima wastewater processing. So this is a potential thing. It's highly likely that might occur, but if you're excluding nitrogen from your mix, then the production of helium is your number one thing, and then you've got your oxygen being produced. So that's it, basically. What they observed, production of helium, excess oxygen, is the outcome that you would expect if it was using ball lightning and trying to fit things into a small box. And therefore, I kind of rest my case. That is kind of what it's doing. Right. Let's see if you've got any comments on that. But that is basically showing from the Parkhomov, Philip Power, MFMP reaction tables how you can show and demonstrate step by step that what they claim to have observed is the most preferential outcome from a ball lightning system. Yeah, silicon dioxide, I think it's like, if you look at the ratio on Earth, I think it's like 52% oxygen, 20-something% or something is silicon. So, like, you know what this system produces. It's a little bit of magic, really. Okay. Hi Wayne, great to have you here. Fantastic. And I have to say, this tool that you produced, it makes understanding these systems so easy, so easy. I pity the people that had to guess in past days gone by. But yeah, thank you so much for your work. Yeah, those UFOs were swamp gas after all. The ball lightning, those long-lived luminous objects are swamp gas. Yes, it's hilarious. It's hilarious. It really is swamp gas. Hi, Crypto Alchemist. Great to have you here. So, energy, like for instance, my gas bill right now, because of various geopolitical shenanigans, is 97% of all of my bills a year and 1 month ago, right? And it's crushing people. They can't do all of the things they were doing just last year. It's crushing because the need to keep yourself warm in the winter and to keep the lights on when you're trying to function is a fundamental thing. And the only thing that kind of like supersedes that is food. And sometimes you're having an interplay between the two. And when you've got a choice of going out to eat and keeping the lights on, you're not going to do that. You're going to buy the food you can buy at the supermarket with the residual amount of money you've got left after you haven't frozen to death. And you're going to eat that. So right now, it's crushing both the income and increasing the outcome. And so it's all down to affordable, cheap energy. And what this does, what we have shown here today, is there is a potential using systems that are employ technology that we have in my view, proven and can demonstrate at will and on demand and repeatedly that the output from one or other end of a cow, the much maligned sacred cow, producing milk and dairy and cheese and beef and all those wonderful things we enjoy in life, it could also provide us all of the energy we need. And because we are converting their farts and their burps into potentially oxygen and useful helium. Remember, you're not getting, I keep saying, like, do you know where the helium comes from when you suck it in a party balloon? Well, it comes from the strategic helium reserve that is formed by extracting the helium that's in the top of oil and gas wells, right? Why is the helium there? It's because the Earth, which is making the oil and gas, not some fossils that died, right? That's true of coal, but the Earth that's doing this linear process, it outputs three things preferentially, right? What we see in Lena. P and Telly saw emission of protons. That's because it produces protons, right? It's a rounding error. It gets kicked out of the system. The second thing it likes to produce is helium. And the first thing that it produces that is not a gas is carbon. So it's not surprising that you get hydrocarbons in a oil or gas deposit, and above it you get helium. It's not surprising. This is like an accelerated version of what the Earth does to give us that beautiful thing, that beautiful, wonderful endowment of Earth-produced abiogenetic, biosynthesized oil and gas. Yes, it takes a long time, right? But we're taking this wonderful gift of nature, carbon, and we're taking hydrogen, this most abundant element in the universe, and we are fusing those into the helium and into the oxygen. And we know nature wants to do this because most of the crust is that. And it, in my view, is produced in this system. We don't have to argue. There's 4.5 billion years of answers there, right? Everywhere you look on the crust, there's plenty of silicon and plenty of oxygen, right? That's what it likes to do. So I think we can keep cows, probably grow more of them, feed more of them, and we can get the milk and the cheese and the butter and take their, what we are being told is a terrible, oh my God, the sky's falling down, gaseous emissions from them. And we can use those to produce all of the clean energy and give oxygen back to people in the world. We can enjoy this process. And it is, in my view, possible because ball lightning is synthesized here. It's synthesized by fluid dynamics, and I'm going to shout out for someone to download this software and do the fluid dynamics that would occur in this system. That would be great. And the turbulence leads to charge separation of one or other type, possibly one at one end and one at the other, which would explain where if you had a virtual anode here, why it would pull in electrons from the environment, and it would explain if you had a virtual cathode here, because the turbulence is forming an exotic vacuum object structure in the opposite way, you would get a discharge from one end to the other. This is consistent with all of the claimed observations of Paul Pantone, and you need charge separation for the production of exotic vacuum objects, and any time you have charge separation, they will form. Even if you really desperately don't want it to happen, sorry, mate, it's going to happen, right? And once they're formed, you can start doing the magic with them, okay? And gasoline is a beautiful gift of nature. It's a beautiful gift of nature. But above that gasoline, and but below the helium, there is CH4. So we could use a bioreactor. We could use a bioreactor to create what nature can do in ball lightning to give us energy at a level that would completely transform humanity. I'm not talking necessarily here about achieving the energy necessarily that you would get from nucleon collapse, which this system might be able to do if it was tuned correctly. And that would just be bonkers level. That's 967 or whatever million electron volts per nucleon collapsed, right? But I'm happy with the 32.450,455 million electron volts from the fusion of 4 hydrogen and 1 carbon. 6.5 million times more energy than the burning of carbon to CO2, which we're all so scared about. And we can clean up this molecule and make the sacred cow the sacred cow. Felix, maybe a spherical GEET would work. Let's start with the GEET that we have and know and love. Verify the effects. Once we verify, we know what to look for. We know what structures to look for in the damage. We know that if we put copper in there and we see certain features on those copper, and if we put brass in there and we see certain features in that brass, and if we look into those active areas of the reaction chamber and we see certain things going on, we know and we can show 100% certainty that it is the same effect. We know what it should be able to do. We know what the US Air Force claimed in 1994, 1995 it should be able to do if we get a 10mm ball lightning. That would provide all of the energy for a domestic home. If you can have a device that you can put in your waste fuel, or you can go out and pick a load of berries and squeeze them and get the sugars out of the berries, and you put that in your reactor and it heats your home over the winter, wouldn't that be a beautiful thing? Wouldn't that be a beautiful thing? We have the understanding to show that the anomalies that were reported by Paul Pantone have a scientific basis. They can't stop us going out and picking berries, goddammit. They can't stop us picking berries. So the Mobius coils are very, very important. I'm probably going to do that presentation next as to why that's important. It works with data we shared over the last 6 years, and you will understand, I think, implicitly how some of the weird effects occur and how some of this energy dumping and retrieval can occur. So EVB says they'll become a berry cartel. I'm sorry. You can go into the forests here in Eastern Europe and you can pick mountains of blueberries. Blueberries in the early part of the year. There's cherries. You know, I don't care if there's worms in my cherry. I just want the hydrocarbon, that sugars. You know, you could probably grow in a very small area enough fructose in sweet corn. You know, there's so many options if you are getting this kind of, even if you have a small fraction of those hydrocarbons or carbohydrates being converted through this process, through the ball lightning process, from carbon and hydrogen to oxygen with a little bit of water in there sprinkled in, right? When you get to understand this, it starts to make sense how you can end up with things like the fuel injector of Stanley Meyer. All of these things are just going to be so obvious, just so obvious. But this is an easy one where everyone in Africa, in India, in everywhere, like if you can go and buy a cheap, you know, they are going to ban diesel generators and petrol generators if they can get away with it. They will ban them. They will ban them, right? They will try and convert everyone to electric, and then somewhere someone will have a energy generation device, and you'll just be paying forever, right? And they'll be able to switch you off at a button. I had the pleasure of being taken cross-country skiing on Saturday for the first time in my life. With Pavlos Ozmira. He's an expert in structuring water. and in plasma purification of air. And unfortunately, he had converted his house off hydrocarbons. And for the first time in living in his family home, in his entire life, he had no electricity for more than a day, and it was well below zero with a big snow blizzard outside. And he didn't have any other options. And I thought, oh my God, this could be the world we are moving towards, where we're not allowed a gas stove in our kitchen. We're not allowed a hydrocarbon-driven car, and we're not allowed animals that provide us healthy, nutritious food. No, we've got to turn this on its head. We've got to use their arguments against them, right? They're saying you don't want cows because it produce methane. I'm saying we do want cows because they produce methane. We do. They are sacred. No one touches the holy cow. I don't know whether you need copper other than where it's defined. I think you just need the turbulence and the charge separation, and really that's it. It's got a yin and a yang, one at either end. These produce your. I mean, it's basically like the idea about getting the rod the right length is it's got to be able to have the temperature gain and enough time for the temperature thermal transfer, plus the organisation of the turbulence and the self-organisation. Plus, it will need to be a resonant structure across it, and the toroidal moments that are involved will need to interact in a certain way. He says actually, so like if you get a rod, and I've transcribed the thing, but I haven't finished doing the cleanup on the transcription, but I'll do that. But if you've got a toroidal moment and it's doing weird stuff to the metal, he says when you do this north-south thing and you go down to the rod and it changes from one pole to the other, that's how long the rod needed to have been to be perfect for that system. And so you're looking at a system where it's kind of like it will be a resonance, or it will be to do with the length of the toroidal moment, where the interaction goes to below a certain threshold or something like that. Like you see this cone. So if it's coming around there'll be a coin. If it's coming up the concave end like this, and you're going into the pressure drop, I imagine that it's going to go like that and produce a vortex like that, and the vortex will be kind of like moving into the back of the cone, and it will be projecting out the toroidal moment in front of it down back through the reactor, and the toroidal moment will have a zone on which it has this critical threshold field, which is where certain matter collapses. And he actually talks about in some of his reactors that when they've taken out the rod has been soft, and in other ones where it's crumbled. And these are things that John Hutchison observed, and I can tell you with a fair degree of certainty, almost to the point of being totally certain, that it is exactly the same effect. The magnetic effect will be that the clusters, just as observed by other parties and ourselves, they are being trapped in the metal like they do indefinitely. Okay. Enjoy your dinner, Bernie. So again, I'd like to reiterate, Dave, myself and Henk, we've gone through some of the videos already, and we've identified, unique things that have been suggested that it was observed. He claims there were about 200 anomalies. So let's see if we can grab as many of those anomalies as possible and get them listed in remote-view.icu, and then we can work through and establish best hypothesis for why each anomaly occurred, and experiments that we can do to verify those anomalies. So this is a real team effort here. Which type of model? What you want to do is have a system. So Ken's asking, what type of cameras would you want to have to observe this? I think any camera would be good to give us the best video of this we have to date. But because the field interacts within a certain distance, and let's try and establish from the available videos how far it is. He talks about sort of like a foot away when he's doing his hand gestures in his videos. So, and there will be a cutoff, okay? In the strange radiation work of Vladislav Zigulov working with Alexander Parkhomov, they have observed it being about 22 centimeters. So I imagine that if you can have a camera that's outside of 22 centimeters, okay, and I don't want people to damage their cameras, so I would start further away and see how good you can get your equipment. But it would be good to have a good macro lens so that you can zoom right into the plasma and get a good focus on the plasma. And what you want then is a high dynamic range. So you want as many stops as possible. You want to have a camera that has the ability to save in 10, 12 or 14-bit dynamic range, and good spatial resolution, that is the high resolution, and good time resolution, that's the number of frames per second. And then you want to change the if you want to see a time slice, you want to have a very short shutter speed. If you want to see the way one frame blends into the next, sometimes you need to like make the aperture smaller so it's all in focus through the depth, and that will reduce the light, so you'll be able to start to see into the plasma, and then extend the shutter time out so that you have nearly as 100% as possible of so if you've got 60 frames a second, you want the shutter time to be open for 1/60th of a second, right? There will always be a little gap, but it means you can see how the plasma moves from one frame to the next in there. And I imagine because the cylinder's going up and down, like if it's 2-stroke, it'll be different from 4-stroke or whatever. There will be some backward and forwarding going on because there will be pressure pulses, and this might actually be critical to how it works. And there might be some tuning processes needed to go on there. He does say that like as the rod slides up and down, it's kind of self-positions itself based on what it needs, and that might be like the plasmoid is the Evo is pushing back on the rod, and the vacuum is pulling it in. So you've got two opposing forces going on in there. And the toroidal moment, of course, is flying out in front and grabbing. Like, you know, if you've got iron, you've got iron has iron 57. It's 2 point whatever or 1.2 or something like that. It's a low amount, but if it's grabbing onto that, it's still able to spin that free thing around. Okay, any other spin matter is going to be able to spin around. So the actual toroidal moment will produce a vortex field in there. So you might not need to introduce a deliberate vortex going in. I think he said in one video it needs to be a vortex that's going in a certain direction. That needs to be verified. Yeah, straight pipes do introduce a lot of turbulence and friction. Yeah, I mean you always get these structures forming where you have any shear, and you're going to get shear wherever there's friction. So yeah. I think if you can run this off basic sugars, and you are getting any small fraction of the 6.5 million times per overall reaction over burning carbon and oxygen, you will not need any other form of energy. Especially if you can close loop this, as I believe was claimed by Amarza. So Amarza is putting the hydrocarbon in with HHO and putting it around, and it's essentially going to be the same kind of process going on, at least in part of the system. And so you know, if you have a system that runs all day long on its own exhaust, you know, that is closing the loop, and you know, it doesn't matter if you're wasting all kinds of different energies that's outputting, because you've got such a gain there, and you're only going to need to use a fraction of it. If we get this right, there will be no need for any other form. That will be true of the PAP. I like the PAP because it's clean. I do believe it has this problem with charge clusters aggregating, and the only way you can get rid of them is dump them, right? To a degree, if you've got a partial bleeding of the oxygen from a GEET engine, because oxygen will, whether you like it or not, capture the charge clusters, it will be belching the charge cluster bound oxygen out into the environment, and that's a thing that exists in nature. So like it's not a thing that is not already around us. What I would advise people is when they are running the GEET, not to get too close to it, and that will be the subject of my next video. It's very concerning, but still don't get too close to it. Because although it's got oxygen in there, although it's got carbon in there, we need to quantify the emissions of strange radiation. We need to quantify the toroidal moment induced far field energy extraction aspects of it. When he describes pulling in electrons, there's a logical reason for that, but I believe it's more going on there. It needs to pull in dark matter, and if it's pulling in dark matter, then that can have effects on biology. SWIFTBIC was very clear about this. There's another video that I'm translating and transcribing, which was followed shortly after Yuri Bazhatov died, and there was panic within the Russian community. And I've got this video where they're all discussing, we've got to get really serious about understanding what's going on here, because we're just all gonna kill ourselves before we have the understanding. And SWIFTBIC gets up at the front of the room, and he's extremely passionate about this aspect. So I need to address this. It is interacting with the coherent condensate in ways. I expect it will be interacting with the coherent condensate in ways that you need to be outside of a certain zone. So that's what I'll say there. Safety, safety, safety. Okay, so it is, I don't know what time it is. What is it? It is 20:00:25, and I have a lot to do, so I'm just going to do a quick overview of what we discussed today. Recap. So this asked humorously, can we run the world on cow farts and burps? One or the other, it doesn't really matter. The methane that is the excuse for giving a bad rap to cows currently, because I like cows. And methane is the thing that comes out, and the claim is the one cow can produce up to 200 kilograms of methane a year. That actually, if you held that in your hands as a lump of metal, you'd have a very flat hand, let's put it like that. But you know, this is an opportunity, not a problem, in my view. Let's make it sacred for the cow. Methane is wasted to the tune of 140 billion cubic meters from oil and gas wells. And wouldn't it be amazing if you could just cap off those wells and sip out through a capillary enough to keep a big energy generator running basically indefinitely, and leave the rest for producing plastics and whatever else. And so potentially the GEET is a system, and when reviewing the GEET claims by Paul Pantone that I've reviewed so far, it is entirely consistent with a charge separation driven, fluid dynamic, self-organizing clustered structure that leads to the production via a low pressure zone ionization
self-organized plasma that leads to a double layer structure as observed and that we've demonstrated on video in Vega experiments, which does capture and transmute matter. And I believe that either end of this is effectively a yin-yang, and that you are getting separation of the molecules in whatever you're putting into the system by this Rank-Hilsch effect going on at the start here, where you have a toroidal vortex going on here. It can increase potentially the temperature up to 200 degrees C going down here, and then there's an interaction. This needs to be verified further, but you can see the so-called hot zones likely caused by the turbulence there, and it is the turbulence here and going along the side where you have this shear-induced turbulence that will, through turbulence, cause charge separation in particles that are charged in that fluid flow that's going around that rod. And you can start off with a beautiful, beautiful, God-given, probably Lena-created abiotic gasoline, which is 1 to 2.5 ratio, or diesel, which is less favorable from the hydrogen content. You can use, as he claims, soda, which is water, carbon dioxide, and glucose and fructose. Glucose and fructose, they are most of the sugars that are produced by plants. And they eventually, they convert these into cellulose. But anyway, C6H12O6. And then you add a little bit of water in there. And like I say, the oxygen is a bystander. At worst, it may be a magnetic binder for the clusters based on the fact that O2 is paramagnetic. And we've shown that it's necessary in Lena, like Sundaresan and Bockris. They only found the synthesis of iron when they were doing carbon arc experiments under water, when they had oxygen dissolved in the water. Nitrogen did not work. Nitrogen did not work. Oxygen did. Nitrogen is fermionic nuclei. Carbon is bosonic nuclei. Oxygen is bosonic nuclei. So they had it work when there was oxygen, not when there was nitrogen. So when they had carbon and oxygen dissolved in the water in its paramagnetic cold state, they produced iron, which means they were able to fuse. Okay, so we know this from that great electrochemist's work and his colleague. And so you can use soda pop, as Paul Pantone liked to joke, and I imagine that you can use a range of common vegetable oils, which is available in large quantities as waste product from the food industry. And I would be very happy to make use of my wife's 3 litres a week waste oil. And potentially you might need, if you're using heavy oils or crude oil, a detergent to emulsify, so that when the entrained bubbled gas comes out, ready before it goes to the fuel processor, this fuel processor, you've got another chamber which looks similar like this, and you might have some crude oil in here and some water and some emulsifier in the form of a detergent, and that forms a bubble. The bubble comes up here with some vapor in it, just like your vapor coming off when you're frying at home and it coats everything in the kitchen over a period of time. You have that oil vapor coming in here with the water, and it goes through this process here, gets atomized, and ends up in your ball lightning over here. You probably need, for reaction on the outside, non-spin material, and things like there is ortho hydrogen and deuterium, and there is helium, which is no spin, and carbon, which is no spin. So I talk through in detail how spin can affect where it takes place in the reaction, and where no spin will take place on the outside of both flux and closed flux in the form of EVOs and fractal versions thereof. And what might be the best fuel? Well, it turns out that things that they're seeing, helium and oxygen, excess oxygen, are the things that are most likely to be produced. And it would not, as long as you've got extra carbon and hydrogen in there, you would not have oxygen reacting, and I showed that that is unfavorable from fitting it into a small box. And if the ratio, therefore, is ideally 1 carbon to 4 hydrogen, the most advantageous hydrocarbon molecule that we should use is methane. And biogas, whether you produce it from your food waste in a bioreactor, or you ram a pipe into a waste dump site, or you find a cow somewhere around you and ask for its poo and put the poo in a bioreactor and say, thank you, cow, for running the power for my family. We can give back the respect that cows deserve for giving us so many amazing things. Now, you know, milk is pretty much one of the only drinks you can drink which has basically everything you need to live, right? Literally everything. It has proteins, it has sugars, it has everything you need. Let's face it, when your baby is an infant and you're breastfeeding the baby 2 years, it can basically survive on just milk, right? It might be sucking all the nutrients out of the mother, but it is living off that milk, okay? And so what a cow can provide us is products that don't even kill the cow, that can provide us all of our energy and keep us alive. It is the sacred beast. The Indians are right about this. You don't even need to kill the cow to respect what it can give us. But there we go. Ruminants can do something we can't do. And that is what you see down on the ground here is one of the ways that nature captures solar energy, and it's intercellulose. They eat grass. Humans cannot process grass. Ruminants can process grass in areas that cannot be farmed in any other meaningful way. Like goats can go all over and eat ridiculous types of vegetation, and sheep can go on landscapes in Wales that you couldn't grow anything else there, and they can convert that grass into stuff that we can use. And so let's celebrate the cow. Let's celebrate ruminants in general and the gift that they give us. So with that, I will say thank you for your time, and let's turn the nonsense, the utter nonsense about global climate change and the need to get rid of meat and the need to remove certain forms of agriculture. Let's turn it on its head. Let's use their arguments and show that there is a way forward that gives us everything we need. Doesn't mean no one has to die. Everyone can get fat, like fat off the calf, it's like the fat of the calf, and live in respect of this wonderful beast, the bovine and the sacred cow. So thank you very much for your attention today, and let's make the world run on cow farts. Buenas noches, dobranoc, good night.